Hi there, this is the practice chapter R test, and as always I am the amazing Mr. Jansen, so away we go. If we look at this first one, we're just doing order of operations here, so we're going to start inside those parentheses, and inside those parentheses we have a couple of things going on. We've got some division, we've got some multiplication, but the first thing I'm going to do is the exponent, which is going to give me a 4. And now back inside those parentheses I've got division and multiplication. And remember, division and multiplication are tied, so I have to work left to right. So in this particular case, I have to do the division first, which gives me a 4. Now back inside those parentheses, I can do the multiplication, which gives me a 16. Now I've got two separate sets of multiplication. Over here, I get a 32. Over here, the 4 times the 1/2 just gives me a 2. And then I subtract, that gives me a 30. Okay? If I look at the next one, I want to solve this for x, so I'm going to simplify and then solve. So the first thing I'm going to do here is distribute that 5. When I distribute the 5, I get 30 minus the 15x equals 5x plus 20. I've got to get my variables on the same side, so I'm going to add the 15x to each side. So now I'll have 30 equals 20x plus 20. I'm going to subtract the 20 from each side. And when I do that, I'll end up with the 20x being set equal to a 10. Now I divide each side by the 20. And really, this gives me a fraction, 10 over 20, which is 1/2. If I look at the next one, I'm using my rules of exponents here. Remember, 2 times 9 is still the same old thing that we've been doing with numbers. 2 times 9 is 18. But now when I do a to the 4th times a to the 3rd, when I multiply two things, I add the exponents. So that's a to the 7th. It's going to be a b to the 6th, and then a c to the 3rd. Okay, so again, I multiply the coefficients, but I add the exponents. For this one, I can start inside these parentheses and start doing some of this division. But take notice of the exponent that's up top here. That is a 0, and anything to the 0 power is 1. So it doesn't matter what I do inside there. Everything's going to be raised to the 0 power. So that one just equals 1. With number 5, I've got a 5 as that exponent out there, so not going to be as easy as the previous one. So this time I'm going to start inside the parentheses. And inside those parentheses, that division, I'm just going to divide each piece. So I do 18 divided by a -9, which is a -2. And now when I divide, I subtract the exponent. So x to the 4th divided by x to the -2nd. I subtract the exponents. That's going to be an x to the 6th. Remember, 4 minus a -2. It's like adding the opposite. And then the y values, y to the 5th divided by y to the 1st. I subtract. That's a y to the 4th. And then z to the 5th divided by z to the 1st is a z to the 4th. And now I'm going to raise everything to the 5th power. And when I raise each of these things to the 5th power, -2 to the 5th power is a -32. When I raise these to a power, I multiply the exponents. That's going to be x to the 30th, y to the 20th, z to the 20th. So again, when I multiply, I add the exponents. When I divide, I subtract the exponents. When I raise it to a power, I multiply the exponents. If I look at the next one, I want to multiply the polynomials. So this time I have a binomial times a binomial. So you can think of this in terms of FOIL, or just think of it in terms of distributing. I distribute the 5x. So that's going to give me a 15x squared minus 10x. And now I'm going to distribute the next term, which is the 3. That's going to give me a plus 9x minus 6. And now I combine like terms, which are the ones in the middle this time. So that's a 15x squared minus x minus 6. And that's it. I got to do the same thing with the next one. The next one I can't use FOIL for. I have to think of it in terms of distributing. So I distribute the 2x to all 3 of these terms. When I do that, I get a 6x cubed plus 8x squared minus 14x. And then I distribute the -2 to each term. That's going to give me a -6x squared minus 8x plus 14. And now I combine like terms once again. I've got the x squareds and the x values, so I've got a 6x cubed plus 2x squared minus what looks like a 22x plus 14. And that's it. Taking a look at the next one, I want to find the missing value for the right triangle, and I'm telling you it's the right triangle, so even though it doesn't have the little box written in there, I still know that this guy is a right triangle because it says so in the directions. So now I want to find the missing side. I have to use my Pythagorean theorem. The a squared plus b squared equals c squared. Remember, a and b aren't super significant. The one that's important is the c value. And in this case, the c value is the 13. It's always across from the right angle, and it's always the longest side. And then it doesn't matter if I plug the 5 in for a or b. I'll plug it in for a. And now I'm going to have to solve this for b. I've got 25 plus b squared equals 169. I've got to subtract this 25 from each side. So I find out that b squared equals 144. And then I take the square root of each side. And of course, the square root of 144 is a 12th. Okay, so my missing side for this one is 12. If I look at the next one, we want to determine if these measurements could be a right triangle. And remember, for all right triangles, the Pythagorean theorem should work, which means if I do a squared plus b squared plus c squared, if these are the dimensions of what could be a right triangle, then a squared plus b squared plus c squared will work. Okay. Again, the important thing is the c value. In this case, it's got to be the 15, because once again, that has to be the largest side of the triangle. So I'm going to do 11 squared plus the 7 squared and see if it equals the 15 squared. That gives me a 121 plus a 49 equals a 225. And then the 121 plus the 49 is going to give me a 170. And that does not equal the 225. So no, these are not the dimensions of a right triangle. Okay? If I look at the next one, we want to find the area of the shaded region. So it looks like we're talking about a pool that has a 3-foot sidewalk around it. And the hint that I gave you is to find the length and the width of the larger rectangle first. So when we look at something like this, if from here to here is 20 units long, and I have a sidewalk that's 3 feet on each side, it means I'm adding 3 feet to one side and 3 feet to the other side, which is a total of 6 feet, which means the overall length of this thing is going to be 26 feet. I do the same thing with the width. If from here to here is 12, and I tack 3 feet on here and 3 feet on here, giving me a total of 6 feet being tacked on, that means this thing is going to be 18 feet going this direction. So now if I want the shaded region, I just have to find the area of the whole thing, and the area of the whole thing is just length times width. And then from that, I'm going to subtract the area of just the pool, which is the 20 by 12 foot. And I'm just going to subtract these two areas to see what this is going to equal. So the first thing I have to do is punch this in and see what I get. So the 26 times the 18, that gives me a 468. And then I also have to do the 20 times the 12, which gives me a 240. And then I have to subtract these two because, again, I'm finding the area of the whole thing and I'm taking away that area in the middle. So when I subtract these, I'm going to get a 228. Okay? So it's 228 square feet. If I look at the next one, I'm dividing each of these. This first one, I've got a polynomial divided by a monomial. And remember, for that, I'm just going to use my distributive property. In other words, I take the first term and I divide it by the 3xy. And then I take the next term and I divide it by the 3xy. And then I take the last term and I divide it by the 3xy. So I'm just dividing each piece. And you don't have to write it out like this, but just to show you that's what I'm doing. Here, the 9 divided by 3 is a 3. I subtract the exponents. That's going to leave me with just a y. Here, 3xy divided by 3xy is a 1. Make sure you have a 1 written there. When we divide things, it doesn't cancel out to be 0, cancel out to be 1. Then here I get a 2x to the second, y to the second. And that's it. The other thing that I might do here is I might rewrite it in descending order, just because that feels right to me. And that's all there is to it. For the next one, I can't just use my distributive property here. I'm dividing by this whole thing. So I can either use long division or synthetic division. Remember, to use synthetic division, I have to have a binomial, which I have because I have two terms, with a leading coefficient of 1, which I have. It's the number in front of the x. And of the first degree, that's an x to the first. So I can use synthetic division for this one. So I take the opposite of this constant term right here and put it in my little half box. And now I write down my coefficients. And remember, I need each coefficient in descending order. And if you look, somebody's missing, and it's the x to the third. I've got x to the fourth, x to the second, x to the first, x to the 0. I'm missing the one in here. the x to the third. So I've got to put a 0 in its place. So I've got a 1x to the fourth, I've got 0x to the thirds, I've got a negative 6x squared, a positive 10x, and a minus 8. And now for synthetic division, I bring down the first term, which is the 1. And now I multiply what's in the box times what's below the line, gives me a negative 4. And then I add straight down, that's a negative 4. And now what's in the box times what's below the line gives me a positive 16. And then I add straight down, that's a 10. And then I multiply what's in the box times what's below the line, that's a negative 40. And then I add straight down, that's a negative 30. And then what's in the box times what's down here, that's a positive 120. And then I add straight down, that's a 112. And then I have to bust out my secret decoder ring. Since these are in terms of coefficients, my answer is also in terms of coefficients. And if we look, the answer here is just the coefficients. It's the 1x to the third, because remember I started with x to the fourth, so it's going to be 1 less. It's 1x to the third minus 4x squared, each term in descending order, plus 10x minus 30, with a remainder of 112. And my remainder goes over the thing I was dividing by, and that is it. Okay? If I look at the next one, this time I'm factoring. And remember, when we're factoring, we always want to look for the greatest common factor first and then go from there. If I look at this first one, the greatest common factor is a 9, so I can factor a 9 out of here right away, which leaves me with x squared minus 4. And when I look at x squared minus 4, that is a difference of squares, so that factors into x plus 2 and an x minus 2. Okay, but always look for the greatest common factor first, and then factor what's left over. Will make things much easier. If I look at the next one, I've got a trinomial. There's no greatest common factor, so I build a bridge. That's a negative 6. Two numbers that multiply to a negative 6, but add to a positive 5 or a positive 6 and a negative 1. And since I've got a leading coefficient of 1 here, I can use my shortcut, which means I go right to my two binomials. Since the two numbers I was looking for were a positive 6 and a negative 1, I do y plus 6 and a y minus 1. If I look at the next one, again, there's no greatest common factor here, so I go right to building a bridge because it's a trinomial. That gives me a positive 12. Two numbers that multiply to positive 12 but add to a positive 7 are a positive 4 and a positive 3. This one does not have a leading coefficient 1. It's got a leading coefficient of 2, which means I cannot use my shortcut here. I've got to split up the middle term. So I'm going to split that middle term up into the 4p and a 3p. Again, I just use those two values that I just came up with as coefficients. So now my equation looks like this, or my expression rather looks like this. All right. Instead of having a 7p in the middle, I've rewritten that as a 4p plus a 3p, which is essentially the same thing. The only difference now is instead of 3 terms, I have 4 terms, which means I can do my factoring by grouping. Okay. Out of the first 2 terms, I can factor out a 2p, which leaves me with a p plus 2. Out of the second 2 terms, I can factor out a 3, which leaves me with a p plus 2. And now this is where the magic happens. I've got the p plus 2 in common, so if I were to factor that out and write the p plus 2 out here, if I were to take that away, if I were to factor it out of each of these, you can see that it leaves me with a 2p plus 3 when I eliminate those. So that's my other factor, is the 2p plus 3. And then number 16, if we look at number 16, no greatest common factor here, so now I look at it and I see 2 terms. 2 terms is usually an indication of one of my special cases, and this one is actually my, my difference of cubes. This is one of our SOAP problems. Remember, it factors into a binomial and a trinomial, so I set up my signs. SOAP, this sign is the same, this sign is the opposite, and this one is always a plus. Same, opposite, always a plus. Okay, and that's true with a difference of cubes or a sum of cubes. So now the thing raised to the 3rd power that will give me the x cubed is an x. That's what goes here. Something to the 3rd power that gives me the 27 is a 3. That's what goes here. And now I just make sure everything works out okay. X times this first term has to equal the x cubed. So that's going to have to be an x squared. And then I'd like to jump to the last one. 3 times something will equal the 27. And the only thing that I can multiply 3 by to give me a 27 is a 9. And then the middle term, I just take these 2 values that were right here, the 3 and the x, and I multiply them. And 3 times x is a 3x. And that's my middle term. And that's it. That's how we do difference of cubes or sum of cubes.